Assalamu alaikum everyone. This is the second last lecture for this session. We are starting lecture number 29 for CS116 Object Oriented Programming. Last time we explored the concept of event logging, and we also explored this special package in Python's standard library called the logging module, which provides a lots of functionality that can help us maintain logs for our applications. In today's session, we'll talk about software testing. We'll see why it is important, what software testing is actually, and why it is important. Then there are some buzz terms nowadays: test automation and test-driven development. We'll see what these terms means. Then we'll explore briefly types of software tests, and then what are the major approaches that you can take for designing a software test. And towards the end, we'll explore, not in much detail, but briefly, the concept of assertions. Untested code is broken code. This is our motto for understanding this simple term of software testing. Actually, this term is pretty much self-explanatory. It simply means that you test your code to make sure that it works. This is the formal definition. The process of exercising code to reveal errors or to demonstrate any lackings is called testing. Now, you see, a code can have two types of bugs: syntax errors or syntactic errors, or logical errors. And we know that we cannot run our program without fixing syntactic errors. And the compiler or the interpreter that you are using, it also helps you identifying those syntactic errors. So fixing those errors and making your program run is one crude form of testing. But your program could have some logical errors as well, which are not so easy to detect. So they are detected when you run your program and test it using different input conditions and see what output your application produces. Now, some programmers think that Python is more prone to logical errors because of its dynamic typing. And we have discussed this many times as well in this course, that since it does not notify you when you are changing type of an object, that can lead to many logical errors, because you might be doing that mistakenly. You are not doing changing that type on purpose, but you are just doing some spelling mistake or so. Python doesn't tell you about it, so that can lead to some extra logical errors too. So today we'll see what Python has to offer when it comes to software testing. So what happens if your program has logical errors? It makes the user frustrated. Like, you might yourself have experienced that many times, that if some software is not producing output as expected, or it has a poor display or poor GUI, or it crashes at times, it naturally annoys you. So that means that design and implementation of a good test is as difficult and as important as the design and application of the actual program. So a program must be tested thoroughly before delivery to the customer. Now, there are four main reasons why you require to perform a software test. This first one is straightforward, that you test the code to see if it works like it should work. The second one is that you ensure that your code continues working when you make any changes. Like, you see, a few lines of code can affect parts of the program that you hadn't realized will be influenced by the changes. So a thorough test is required to reveal those logical errors. Then testing ensures that developer understands the requirements properly. Like, I'll show you shortly that there is a technique which is used nowadays, and it is called test-driven approach. What happens there? You write the test before starting to code the program. So writing the test even before starting the program, it can give you two advantages. The first one is this one, that it can help you clear many input and output requirements of your application beforehand, like before starting to code your application. And secondly, it can help you design good maintainable interfaces. Like, it can help you design or decide on what functionality you have to provide in the interface of your application. Now, this is another buzz term, test automation, which is used a lot nowadays. Test automation simply means that you automate testing process. What is a testing process? In testing process, you provide a set of inputs and you see if your application produces the expected outputs or not. This is simple testing. So what you can do, you can write another program which is called a test program or a testing software, and that software can do this testing for you. Like, it can supply your actual application with some set of inputs, and it can compare the outputs produced by your application with some predefined outputs. Now, what advantage does it give? The first advantage is that if you are using some software to test your program, then that takes seconds or even fractions of seconds. Like, you can run a lot of combinations in just a few seconds, rather than doing that manually. If you are doing that manually, that might require a lot of time. Then if you know that we have to test our program repeatedly, like, let's suppose you make some changes to your program and then you have to test it again. So this automated testing, it helps in repetitive testing as well. Then we know when the size of our program, it grows larger, then it can have a lot of paths, like if else paths and loop iterations that we might not be able to check by manual testing. So automated testing is again a good idea in that case. Now, commercially, there are a lot of softwares that are available in market for test automation. Selenium, Test Complete, Catalan Studio, they are some of the popular test automation software, but you can write simple test automation for your application by yourself as well. Now, this is a term that I was talking about, test-driven development. This is the motto, right? Test first. So what we used to do traditionally, that we used to write code first and then we used to develop test for our code. Now, the problem with this approach is that many design flaws, they are revealed in the later stages of your program. Like, after you have developed most part of your application, then you come to know that there are flaws in your design or in your input output strategy and all. So as we have discussed this before as well, that a good design leads to lesser effort in development stage. So if you are facing with some problems, with some serious problems at later stages of software development, then that can be expensive. Like, you'll have to redesign your software again if there are some major bugs. So a better approach could be test-driven development. So what you do here, you first develop the tests, and as I told you earlier as well, that such pre-written tests, they help you understand your application better, and they also help you in developing good interfaces, maintainable interfaces. So in this approach, what we do, we first write the codes and then we first write the test and then we subject all new application code to those predefined or pre-written tests. Now let's see some more terms related to software testing. These are types of testing or classes of testing. The first one is unit test or unit testing. Unit test means that you test a single unit of your application separately, or you test each unit of your application separately, and this pertains to modular approach of your program. Like, we have been practicing this since beginning, that it's better to divide your program into smaller modules, into smaller functions, or into classes, or and then you test those classes or functions or even methods, individual methods, and then you integrate them to your application, to the rest of the application. So writing and then testing smaller codes, they help you develop a program a lot faster than developing everything first and then testing them in just one go. So this is called unit testing, that you test each unit separately. Then a complementary term is integration test or integration testing. Integration testing means that you put all your units together. Like, you have tested them individually, separately, and now you are seeing that how they interact with each other, or you put all those units together to form the final version of your application. So we know that when we do that, a lot of new bugs they come to surface, and this is called integration testing. Finding those bugs and removing those bugs, is called integration testing. So if this test fails, that it means that the pieces of your application, they are not working together as expected. Another type of testing is regression testing. Regression testing means that sometimes what happens when you fix a bug, it can cause some other bugs. Like let's suppose you are done with unit testing, and then you come to integration testing, and then you fix some bugs that resulted from integration testing. Now, fixing these bugs, they might cause some unit testing bugs again. Like it can cause your units to malfunction in some other ways. So what you have to do after performing the integration test, you must go back to the previous stage and you should do the unit tests again. This is called regression testing. So if regression testing fails, that means that your application is not behaving the way it was behaving previously. And that obviously happens when you try to fix some new bug that can, you know, disrupt something else that you fixed before. And fixing new bugs can bring those errors back into your code. And then comes acceptance test or acceptance testing. It means that your application is doing what customer expected it to do. This kind of testing is usually done in the end. In When you have done everything, you are done with all kinds of testing at your end, you just give your application to your quality assurance department or the test department, or you can simply deliver the application to the customer and ask them to test it for their expectations. So this kind of testing is called acceptance testing. Now, alpha and beta testing, these are common terms, and many of you might be aware of these terms, alpha testing and beta testing. Actually, all those types of testing that we have seen up till now, those 4 types of testing, they are categorized as alpha testing. Alpha testing is basically done by the developer, and beta testing is that you just bring your software in market, or you give it to some limited users and ask them to use it so that they can discover more bugs in your application and you can fix them. So this is sometimes called user acceptance testing or real world testing. Now let's see some testing approaches. The 2 major approaches used in software world are black box testing and white box testing. So let's get an overview of these 2 types of testing. Black box testing is done without the knowledge of the internal structure of the program. Like the tester does not need to look at the code. So what's the purpose of such testing? The main purpose is to test the behavior of the software. And it basically focuses on the end user perspective. Like you do not need to know how that application has been implemented. The tester just tests how that application is behaving in the real world. Now, since the tester does not need to know about the code or the internal implementation of your application, that means that this type of testing, it can be done by anybody, even other than the implementer. In fact, if somebody who is not the implementer tests the code, that's even better, because that helps us avoid inherent biases like which the implementer himself can have. For example, if I'm writing the code, let's suppose I know how my code works, so I'm testing it again and again on the same kind of values, like let's suppose on positive values only. But if somebody else tests my code, then he or she might think of some unusual values also. For example, negative values or some extreme values, which me being the implementer did not think of, right? So that means it can be done by anybody else. In fact, it's better if somebody else does this, and mostly the quality assurance department performs these kinds of tests. And then you can ask the client also to perform this test. And since this type of testing, it does not depend on the internal implementation. So if you are correcting the errors and you are changing the code from inside, then these tests, they can be reused. Like the tester does not need to design new test every time the code is changed or some bugs have been fixed. Okay, I think by all this explanation that we have just discussed, you might be able to gather it by yourself as well, that such testing, it can be used to test user interfaces or the end product, the final end product. So that means that it can reveal gaps in the functionalities, issues in user interfaces, improper use of structures and databases. If your program is crashing at places, that can also be discovered by such kind of testing. So this is considered as one of the essential testing approaches in the software world. Now, here are some rules that can be used for designing black box tests. First of all, consider possible paths through the specification, because the implementer will always provide some specification. Like you see, like the type of inputs that you should provide to an application, some ranges for which that application works. So the first thing that the tester can do is to test that application using those specifications. I'll show an example to you shortly. Then the tester can go for boundary cases. Like if we are talking about numbers, then the tester can apply very small and very large values and see how the application behaves. And if there are data structures like lists or dictionaries or strings, then extreme cases could be an empty list, or a list having only one element, or a list having too many elements, or some typical cases. So that's how black box tests can be designed. Now let's see some examples. Now this first example is a very simple one. Here we'll simply write a function that will calculate power of a value. We have done this before as well. Now these are some specifications given by the implementer. The function will take two arguments, base and exp. Both base and exp, they can be of any type, integer or float. If exponent is 0, then this function returns 1. Otherwise, it calculates base raised to power exp, and that value is returned. So here is the implementation. But we know that the tester, the black box tester, will not know about this internal code. The tester will be provided with these specifications only, and the executable file, of course. Now here are some test values that I could think of. Now if you see the leftmost column for base, here I have provided a variety of values. If you recall the specifications given on last slide, base, it could be an integer or it could be float. So I tried on different values. Some are integers, and some are floats. Then I also tried on some extreme values like 0, negative values, and 1009 is can be considered as a very large value. Then in exponent column, you see again I tried integers as well as floats, and then I tried extreme values like 0, negative values, etc. And then in the last rightmost column, here we have some results. These are the results produced by my code. And you see, we can see some potential errors here. Like if you see the first case where base is 0 and exponent is 0, since exponent is 0, it is returning 1, but 0 raised to power 0, it could be an undefined value, right? So we can fix this. Like 0 raised to power 0 is a special case, and this should be treated differently apart from other cases where exponent is 0. Then you see there are some very large values after the decimal point. So rounding can be considered. It depends like how the end user wants it. And then if you see the last value, it's an imaginary value. So this could also be a potential problem. Like did the user think about it? do they want this kind of output in their application or not. So you see, there are some cases which might not be tested by the implementer himself or herself, and they are resulting in some, distinct outputs which could be, undesirable by the user or the client. In this example too, we'll just see, that list case, like how you can test the extreme cases on a list. So here what we'll do, we'll simply print a list in a pretty way, like we'll print some headings, we'll print serial number, and so on. So these are the specifications. This list can have any length and any type of elements, so there is nothing specific about this. And here is the simple implementation. This function takes a list, it first prints these two headings, and then okay, there is a counter also for serial number, and then for every element in list we simply print it along with the serial number. Here are some typical test cases for this list. The first one is the typical case actually. Here I am providing 3 elements in a list, and you can see the results produced by my application. Now there are potential problems with this result. The first one is the alignment issue, and then we see that serial number is not incrementing. Like, we do not have to see the code to detect these errors, they are pretty much obvious here. Then in second line you see we are passing an empty list and it is simply printing the headings. I think a better approach would be an empty list message. So we should have tested for an empty list at the start of the code, and we can print some empty list message. And in the last case, if we are not passing anything, then it produces an error. That means the code is crashing. So this is not good. What can we do? One thing that we can do here is we can put this into try except block, right? Otherwise, we can set some default values also for arguments of the function. Now let's come to the second type of testing, and it is called white box testing or glass box testing, and it is just contrary to black box testing. So in black box testing, we were treating the code as a black box, like the tester doesn't know what's there inside. But in this type of testing, as it is called glass box testing, this means that the code is visible to the tester, right? It's like a glass box through which you can see inside your application. So the main purpose of this testing is to test the internal operation of the system. And it tests all the structures and conditions and paths and branches that are there in your program. You see, we use a lot of if-else structures and try except blocks and loops that run through different number of iterations for different cases. And when we are applying some testing conditions, we usually do not test all the paths. Like, we never make sure that all if and else paths they are tested. So this white box testing makes sure of that. And obviously it requires programming knowledge, because the tester should know how, should be able to understand the code first. A glass box test is called a path complete test if all the paths through the code are tested. Like, as I told you that your code can have multiple if-else paths and try except blocks and other such cases. And if you are designing a test in which all those paths are tested, then that test is called a path complete test. But you see, even path complete tests, they are not guaranteeing that all the bugs are removed, but they can remove a majority of the bugs. Now, here are some rules that can be used for white box testing. As I told you, if you are using if-else structures, then both if and else blocks, both should be tested. Then if you are using try except block, then try and except both should be run at least once to see if they are working properly. Okay, now in case of loops, the problem with loops is that you can be running a loop thousands of times or even 10,000s of times. So it's not possible to write tests to go through each iteration separately. So what we can do, we can go for some boundary cases, like you can test a condition when loop is not entered, when loop is entered exactly once, and then some typical case when loop is entered more than once, and then you can add another condition to here when loop executes to its complete length. Now in same is the case for while loop, but usually in while loop we use some loop exiting conditions also, like that break statement, although that break statement can be used for for loops also, but mostly we use them in while loops. So if you are using any such conditions, then you should write test to test those exiting conditions as well, all those exiting conditions as well. And then comes recursive functions. Recursive functions, they are like loops. So same rules, they can be applied to recursive calls as well. Like recursive call, when it is not run at all, when it is run just one time, and when it is run more than one times. Now here are some simple examples. In first example, we are just trying to find if a value is positive or not. So these are the specifications. The value is an integer and the function will return true if the value is positive or 0 and false otherwise. So this is the code that I have written. If x is greater than equal to -1, it returns true, and otherwise it returns false. Now let's see what kind of white box test cases we can design for this. Now, since we are using a simple if-else structure, so my test cases should be such that I should enter the else block as well as the if block. So here are some cases. The first one, -2, it will surely take me to the else block, and here it is printing false, which is correct. It is not a positive number, -2. Then for +2, it is printing true, and then for 0 it is again printing true. So that means last two cases, they are executing the if block. Now you see, this is a path complete test, because I'm going through my else block and I'm also going through my if block. But there is a bug that I left in my code, which is still undetected by these two cases, although I'm executing both the blocks. But if I test my code on this, some of you might have noticed this in while I was showing you the code as well. Now this -1, this condition was wrongly mentioned in my code. I wrote that if the value is greater than equal to -1, then the code should return true, although the correct statement should be that value should be greater than -1. So I introduced that bug intentionally in that code, and you see the point that I wanted to make is that see, the first three cases, they are testing the if and else block, and I can see that my code is working properly, but still there was a bug that remained undetected, and that was for this partition value -1. So the only purpose of showing you this is that it's not always that easy to design a white box test or glass box test, and usually they are very, very expensive in terms of time, and they become really complex when as your program size grows. So this example is just to show you that how you can do that, how you can design a possible test for a very, very simple code. This is, I am repeating that same print list function as second example, same specification. The only thing that I have changed is that I have corrected those errors that we pointed out while doing that black box test. I have fixed this, alignment error, and I've also incremented this serial number plus. Now let's see what test cases we can design for this when it comes to glass box testing. Here are some possible test cases. Actually, they are almost the same. In the second last row, I'm not entering the loop at all. And then in the second example, I'm entering or executing the loop exactly once. And in the first example, that's a typical one. And the last one, I have not corrected it. Like I have not handled that exception, so that error still remains. Now, what Python has to offer, one technique could be assertions. These are some programming structures that you can put into your code, and they can test validity of some inputs, some random inputs in your program. Uh, Actually, they are just like putting those try except blocks in your code. Then Python also offers some frameworks, some sophisticated packages also for this testing purpose. One that comes with standard Python's standard library is unit test module. Then there are some third-party packages also like PyUnit, Nose, and DocTest. And these frameworks, they provide you facilities to build your tests in easier manner, and then you can run your test. And they have specific methods by which they display the errors to the user, to the test runners, right? Now, since we do not have much time, so we cannot go into the details of these packages, but I'll show you how you can put assertions in your code. Now, let's see this simple concept of assertions. Assertions, they are basically treated as debugging tools, and they help us detect bugs in our code at earlier stages. And we know that the later you detect a bug, the more expensive it becomes. So these assertions are useful in many conditions. Now let's see the syntax first, or let's see how Python implements these assertions, and then we'll come to the advantages of these constructs. Now Python provides a keyword called assert, and what you do, you just write this keyword followed by a condition, a simple condition, we use conditions in if blocks. These are similar conditions. So you are simply testing a variable or an object against a value, and if the condition is met, then nothing happens, or you can say that your code flows normally. But if this condition which is asserted is not met, then your code raises assertion error. Basically, assertion error is a kind of exception which is raised if an assertion is not met. And how you make something an assertion, you just put that keyword of assert in front of that condition, of any condition, right? Now the most common use of these assertions is with input values. Especially when you are inputting some value from the user, you can use this assert statement to verify that value against some range or some specific value. Then you can use this to check parameters to a function. Like within a function, if you want to see if the user has passed the correct parameters or not, there you can use this assert statement. And then if that function is returning some value, then that value can be checked for some specific value in the main program using this assert statement. In fact, these are not the only uses. You can use this statement anywhere in your program where you find it feasible, but these are the most common uses for this statement. So what advantage does it give? What happens here, whenever this assertion is not met, then your program halts or it stops. That means that if you are receiving a wrong input or an unexpected input from user or from some other part of the program, then your program simply stops, and it helps you, in fact, it saves you from propagating bad values to the rest of the program, which can cause your program to crash later, or can cause your program to go into some other bigger error later. So assertion, it basically points out where the error is actually happening, especially if that error is happening in some input condition or in some value of an object or a variable. So this is kind of a defensive programming, like you prepare for the wrong values before time. Now let's see the syntax and some simple examples for assert keyword. Actually, we are already familiar with the concept of exception handling, so that makes it even easier for us to understand this. Here is the syntax. Assert is the keyword written in green, and then you can provide any Boolean condition. After that condition, you can put a comma and provide an optional message. Now, this is the message that will be printed when that assertion error exception will be raised. So this is optional, like this comma and this message is optional. If you want to put it, that's fine. And if you do not want any, custom message, then that is also fine. Now here is my first example. In this example, what I'll do, I'll write a simple function that will calculate average of some numbers, and those numbers will be passed as a list to this function, right? Now what I want to enforce here is I want to enforce the user to pass, or I can say that I want to check that if user has passed a non empty list. Like if user is passing a non-empty list, then I'll calculate the average. Otherwise, I'll raise this assertion error. So let's see how can I do this. Okay, this is my function. Here I'm passing that parameter grades, and I'm expecting this grades to be a non-empty list of integer values. So here is my statement: assert length of grades is not equal to 0. Now you see, in assert statement, I provide a condition that I want to be true. So I want length of grades to be greater than 0, right? So this is what this statement says. So if length of grades is greater than 0, if it is not equal to 0, then it's absolutely fine. I'll come to the next step, which is this. I'll calculate simply the average, and I'll return that average to the caller. Otherwise, that message, no grades data, that is written in that statement, in that assert statement, it will be passed on to the exception. That exception will be raised, and this message will be printed on screen. So let's write some test code. In this first statement, I'm passing some valid values. So this is absolutely fine. When this list will be passed to that function average, length grades is not equal to 0. This condition is absolutely true because length of grade is equal to 3. So my program will continue to the next statement normally, and it will return this average. So I expect something like this. Okay, 126 is the average of these three values. Now in second statement, I'm passing an empty list. Now in this case, that assert statement will be false. So here assertion error will be raised. Now you see, we are not handling that exception here. So what Python will do, it will simply terminate my program, and it will print the stack trace at the output. And this message, no grades data, will be printed along with it. So this is the output that I'll see. Now you see, because of the shortage of space, I put those 3 dots there. You can just go and run it from the file and see the complete stack trace. This is a second example. Actually, in this example, I'll simply handle that exception which was left unhandled in the last case. So this is the same thing again. So here's my code. Now I'm placing my assert statement within a try except block. See, and that error message that I was supposed to print when exception is raised, I'm putting that in the except block. So you see here I'm catching this exception specifically using the class name assertion error. Otherwise, if you're not using that name, then also this except block will catch this exception. Now here is my test statement. Since this was not causing any error before, so it will print the same output of 126 here. Now in case of the second statement, no grades data should be printed because this will cause assertion error, and then I'll come to the except block, and there this will be printed. Okay, lastly, none will also be printed, but I'm not explaining here why that none has been printed. You should be able to figure that out by yourself. A quick recap. Testing of an application is as important as its development, and sometimes it is as complex or even more complex too. Different types and techniques of testing exist to suit demands of an application. Today in this lecture, we just saw a brief overview of these techniques. You learn more on these techniques in some later course like software engineering in third year maybe. Then, like we know that Python has a rich set of libraries. So Python offers some really good libraries for test automation as well, which we were not able to explore because that's pretty much out of context for this course. But we saw this tool, assertion, and we saw that this is a very handy and small, simple tool that can be used to test values um, before they are passed to the later part of the program. So that's it for today. Thank you.